Let's talk about quicksort algorithm. This is a divide and conquer algorithm that is recursive. So this algorithm repeatedly partitions the inputs. What you see here is supposedly this is a string array, right? Like, containing letters A through Z, and they're random. Okay, so this is not A through Z in that order, but B, K, G, W, right? X. These are random, right? Elements that are in a random spot inside this array. The first thing that we do is at each split, this is divide and conquer. So what we're doing in the very first split, right? This is our first split, is that we choose a splitting value right in the middle. So this splitting value could be, a value corresponding to letter K, corresponding to letter Z, W, X, Y, Z, doesn't matter, okay? In some textbook, this splitting value is also what we call pivot. I'll use these, two names interchangeably in this lecture here. So regardless, the very first step is to basically group all of the elements that you have on the left side here. Let me just use letter R, L here, and this is group R, representing the right group. All of the elements on the left side should have a value smaller, right, or equal to pivot or splitting value. All of the elements on the right side should have values, okay, greater than the splitting value or pivot, right? So, or you can define it as such that the left side is less than pivot, right? The right side is greater than and equal to pivot. It doesn't really matter, but the point is that you want to use the splitting, this value to to divide, right? To divide your elements up. As you can see here, when you get into the recursive, right, side. So this is recursion, right? There's the left side as the right side. Let's just focus on the left side here. This is another split we're looking at here, and there is going to be another splitting value, okay, and or pivot, splitting value or pivot. Now, this splitting value and pivot is different than the original, right? The first splitting value. So at each step along the way, right, in each tree, right, branch, you will need to find a splitting value, right, a new splitting value to pivot each partitions. So this partition goes on until you have nothing to partitions anymore. And if you look at this whole thing, quicksort from a process standpoint, it looks very similar to a heap, right? Where all of the values sitting on the left side, smaller than the root, right? But the values sitting inside each of these buckets, they're not necessarily sorted, right? They're just smaller, right? Than we know. And that's the whole point, right? Having this quicksort to be able to quickly sort them out by divide and conquer all of the values that we already know that is smaller than. So the sense of the order is being established, right, from top to bottom until, but by the time you get to the very bottom, the whole thing would have been sorted. Now, the other thing to note is we are not creating additional arrays here. This is all the same array, okay? We're using the same array. So what is being divided here is a invisible boundary, which uses the index to specify the location of the split or the partition boundary. So there's the movement of these pointers moving around from left to right, right to left. Eventually, whenever a decision is made, right, the element is in a unsorted fashion and they need to be sorted, you see a swap. So there's a whole bunch of swap going on, and all of this, right, just wanted to reinforce it, all of this is swapping in place, meaning there is no additional cost. Okay, there's no additional memory required to host these temporary or variables that are sorted in from the standpoint of being a temporary variables, and you have to transcribe it into an original one. No, there's not. So quicksort is very efficient memory wise because it uses it in place, and especially when you're using an array that is with random access, O of one access into the elements, and doing a swap is a constant, right? This is extremely fast log actually n log n time complexity for quicksort. Anyway, so this is a quick summary quicksort, let's just look at from the standpoint of recursion, how a recursive call like quicksort could be established. So the recursion, a recursive call starts here. So as you recall from the previous recursion chapters that we talked about, you have, for recursion to be in place, you have to have both the base case and general case, a way to generalize the whole thing. So the way that you would generalize the entire algorithm is to split them into 3 parts. One is the split part. So this is what we call the partition. This partition is probably the bulk of all of the logic that we need to describe. So this is the method. Otherwise, there's a quicksort and recursive quicksort that basically split all of the elements based on a splitting value, right? So this splitting value is what we call pivot. That's general case. The base case is if the size is less than 2, do nothing. Why? Well, if you have only 2 elements, right? And actually, no, in this case, less than 2. So if they only have 1 element, there's nothing to sort. You're done, right? So this is how you recurse, back up, and complete the rest of the work. So the divide and conquer basically ends at size equals 1. Or even sometimes size equals 0. So if size is 0, that means there's nothing in there. In that case, since you're not really checking to see the nullness of the input, you can base on the size of it. And what is the size? Size is last minus first plus 1, right? So you can imagine if you have some input and that has your first being here, right? This is your first, right? And then your last being, last of the element. So the total number of elements that you have in there is last minus first plus 1. So this is the general formula for computing the number of elements you have in there. So once that size goes down to 0, goes down to 1, less than 2 in general, you don't want it, you just return it, okay, at that point. So this quickly wraps up quicksort, but the bulk of the logic actually sits right in here in a split array. In the next video clip, we're going to talk about the split or the partition logic to complete the discussion on quicksort.